But so the first thing that we're going to talk about is just to get into a bit of the history of why I think this is interesting. So federation is a word that's tossed around a lot. We have federated identities. We have the concept of email, of various systems talking to each other, and people kind of get confused about what federation really is. And so it started a long time ago. We had Bob and Alice. They wanted to send each other mail. And so how did that work? Bob just knew Alice's email address, alice@yahoo.com, sent it. Nobody really thinks about how this works. But in essence, it's just DNS. It's just lines in a config file somewhere that says, okay, Gmail, look up where's yahoo.com. We do this now with serve records. Autoconf is a big idea in this, but IAM has never really done this. People have talked about it since the late 90s, and this has been the holy grail. Big tenanted systems where people could talk together, or hosted systems where everything just kind of worked. And the view is still somewhat like this. You're running 3 different clients, you have really weird names, and you can only talk to people within your silos. So if I get a friend who is on AOL and I don't run AIM, I needed to go get it. So the goal of federation is you're one person. The reason that the picture's changed is because the new players are all talking XMPP. So a few people are still lagging behind, but most of this is working over XMPP. And so the big point of federation is you only have a single identity now, or we're working towards a point where you have a single identity, and you can talk to everybody you want to talk to. So, has anybody heard of XMPP before? Cool. At least a few people. So XMPP is also one of those things which is talked about in reverent tones and gets a little confusing. But the basis of XMPP, think about it as a transport for building other protocols. And when they put this together, they really couldn't make a decision on exactly what protocols they wanted to be able to support. So they'll pretty much support anything. So it is a layer 7 transport, and you can bind it to anything. The original documentation said you could run it over UDP or you could run it over TCP. It runs over HTTP now. It runs over other various binary protocols. But it can run over any transport that can support sending messages back and forth between endpoints. And XMPP is a structured XML document, which seems a little weird because it's a document that starts out, but you don't have the whole thing when you begin. And at some point in the document building process, you'll actually start all the way back at the beginning and throw out the document that you have, except you keep the state that you build up as you were parsing it. And there are 3 main building blocks. They call them stanzas, and they're message, IQ, and presence, which were named for the first primary workloads. So building block number 1 is message. It's pretty easy to think about. You want to send somebody an IM message, and you have a body. But it can also have a few other ideas. You can have subjects for it. You can put thread IDs in it if you want to try and tie different messages together. And you can get really, really complicated with it, which leaves us room for screwing around, because you can have alternate representations in your message. So the first subject is in English because the primary language of the stanza is tagged as English. If they left this off, you're supposed to assume it's English. But there's also a French tag and a French body, a thread ID that says who my parent was and what my current thread ID is, and also you can put XHTML into the body as well if you want to have formatting. So one of the interesting problems with this, besides the fact that you run into interest with Unicode parsing and homophones, is if you're running compliance on this thing, what do you actually log, and who actually saw which body? You're not quite sure. But in terms of building protocols, message is also kind of like UDP, and it's also a bit like TCP if you add in message acknowledgments, but to start out with, it's UDP or push. So the idea is we needed a way to send a message to somebody else who hadn't really requested it. The payload of a message in XML schema contains an XSNE. Every one of the stanzas contains an XSNE. So after the supplied elements, you can put pretty much whatever you want in there. So an example of a new protocol is when you're typing in an IM client and the other side sees, Jason is typing to you right now. You need some way to signal that. And a protocol that they put in there is called chat states. So I send a message. It doesn't have a body. It just says Bob is composing. And additionally, you can request receipts to say that Alice actually got this message or Alice's client did. So those are a couple of different ways to build protocols. And then additionally, you can get an error response back, but like UDP, it's not required. So you don't necessarily know whether something made it or not. It depends on whether the endpoint wants to respond with an error. So presence is a multi-purpose block which allows you to subscribe to something and allows you to get notifications. So it's both asynchronous and it's a publish-subscribe system. So an example of publish-subscribe is you fire up a client and you add a contact, and you're going to send a message with the type subscribe, and that endpoint needs to respond to you. It can tell you unsubscribe, it can tell you subscribed, but it needs to respond to you in some way. But then I change my presence and I set myself to away. So I just send a message and I don't expect a response back. And in a more complex manner, if we start talking multi-user chat, we've just extended the presence model, because this bottom one is saying Bob wants to join a channel named XMPP chat, and he wants everyone to know him as the name Bob Ryan. So the other problem that you can play with is that presence relationships are long-lived and they're unidirectional, which is interesting. One of the problems with actually talking to another client is that for most of the questions you want to ask, you need to have an established presence relationship. But then you show up in somebody's contact list and they know about you. But that doesn't have to be the case, because you can be accepted on their side and they can not send you a request for presence as well, so you don't show up in their contact list. So just to sort of show the slightly confusing state, you start out in a state of none, neither side is actually subscribing to each other, and maybe Bob sends a subscribe. So Alice's server now marks this down and it says there's a pending response or a pending subscribe from Bob, so pending in. Alice needs to do something, so the server's going to send her a message. Do you want to accept this or do you want to reject it? And if you accept, you only end up in a state of from. So both servers record that Bob is subscribed to Alice. So Bob can now talk to Alice's client as much as he wants. The server will let that through without ever actually letting Alice subscribe back to him. So the last one is IQ. And IQ is kind of the main building block. It's request response. It's like HTTP. It's like internet message. You always have to get either an error or a real response back to any request you send. And so you build this up as a get or a set on an XML namespace, and you get back either a result or an error. You always have to have an element that defines what you're asking, and you can address anything. So I can address a user, but a user may also have a bunch of endpoints. and I can address each endpoint individually. I can address a server. Some workflows, like multi-user chat, are built up as a component, something that attaches to the messaging backbone. And I can address components, and I can address channels, and pretty much anything that has a name, which has to be everything in XMPP, I can ask questions of, and I might get responses back. So the basic syntax is that I have an IQ, it's of a type get, and I have to put something in there. So maybe I'm querying a roster. A roster is the list of people who are on my contact list that I care about. Or maybe I'm asking for some information about an entity, which would be a disco info. So XMPP is a big transport for building more protocols. And it started in '99 with just a project that some guy was working on, and they quickly founded Jabber Inc. And started competing in the instant messaging space. And so over time, we've kind of gotten a big set of baggage in the protocol. So if you start looking at this, there was the pre-RFC time where for a while there just was no real documentation for it. They started documenting it. Somebody said, you should bring this to the IETF. And then we got 3920 and 3921 out. And so you have this history of pre-version 1, and then the version 1 protocol, which is 3920 and 3921. And so if you read through the RFCs, they're very ambiguous about how you have to handle stuff, because you need to be able to handle all of the mistakes that they made before they started doing the RFC. And at some point they came up and they said, okay, we need to standardize a bit more. And they came out with 6120 and 6121, but they left the version at 1. And they've put some stricture around some of the processing of your XML elements, except that you still have to be backward compatible with 3920 and 3921 at the same time. There are also a bunch of support RFCs that change, like how to deal with internationalized characters and how to deal with naming. And then additionally, there's this thing called the ZEP system, which is the Jabber extension protocols. And there's 314 of them published today. And they're RFC-like, and they're maintained by the Jabber Foundation, xmpp.org. And those are the places that specify things like, how do I ask a name for information? So the last piece is the government is also stepping in. They've decided XMPP is really interesting, and so they have a big document called UCR 2008, which has a section, Unified Communications Requirements. It has a section on XMPP. So they have competing requirements with the RFCs and competing requirements with the old RFCs. And then on top of that, you have a bunch of implementations. So overall, XMPP is a bit of a mess, which is kind of fun. So why are we talking about XMPP? I asked you guys whether you use IM in the workplace, and what I generally see is people still think IM is kind of a social toy. You use it for setting up an after-work beer, or maybe just catching up on the weekend or something, but you don't use it much for business. And back in the early 2000s, when I was doing security architecture for an IM system, I wanted authentication, and what we were told was this is the most important thing an IM system can have. And so all of our features got cut for the smiley. So in general, what's the attack surface of instant messaging? Anyone have other ideas beyond these? Like, is there stuff that you deal with on a regular basis? I'm just curious. So it seems like people are still talking about the same thing. It's like password policy. People are still talking about password policy. For IM, it's phishing. Spam, it's the same thing. It's trying to get people to do things that you want them to. Installing malware there's still regulatory compliance. Most people, when I talk about IM, roll their eyes. They're like, compliance. And compliance was a problem in 2002, 2003, and most of these were. But the vendors caught up, and everybody thinks we're okay now because we have tools. Except IM has grown up. And so instant messaging is a neat afterthought in Link in same time, but the UC market is much bigger than that. And right now we're at about a $4 billion market cap, and the PBX replacement cycle, which is what people are going for, is about 3 to 7 years. So everyone is now competing in replacing corporate phone systems. And your phone looks like this. It is an IM client. It's also a video chat client. It does audio, it does video, it does application sharing, it shares your desktops, and it's incredibly powerful. But it's also always running now, and it's running on your phones, which is pretty exciting. So I got involved in this back in '99. We started a project to do a group chat system for financial services, and the idea was a federated banking network where every person could come together in the investment banking world and they could do their trades. Phones were annoying and phones were recorded. The squawk boxes that you had down on desks on the trading floor that broadcast news were antiquated, and you had to sit there and listen to them. So you could start putting out all of your trade ideas and actually conduct your business over instant messaging. But the problem was that bankers were doing business over AOL and Yahoo IM because the people that they actually wanted to do business with were there. So this is a screenshot of something called IM Trader, which was built to do trade business over AOL instant messaging. The other screen is mid-2000s, and that was Reuters' play to create this federated system that was going to bring all of the bankers onto the Reuters platform and get them away from Bloomberg, and still traders were doing business over AOL. So the private sector has failed. We never managed to drive instant messaging to a single protocol. We got really close. We got to the point of SIP and XMPP, and the big vendors, Cisco, IBM, Microsoft, were all running on SIP, except that this little guy Jabber came along, and they were selling into the government, the United States government, and so you could never actually get rid of XMPP because the US Department of Defense is a big market. And finally, the DoD has spoken. And so from this point, actually last year, XMPP is the new cool, and everybody's moving to it. So Cisco bought Jabber, and you can now talk XMPP into their phone systems. You can talk XMPP into Microsoft's phone systems pretty soon. And Same Time has worked over XMPP for a long time with bridging technology into SIP. And the other fun thing is the DoD has said you must federate. So you have to have a way for your system to sit out on the internet so that when I pick up my phone and call somebody at a contractor, it actually rings through and I can talk to them. And this is the specification if you ever really have a need to read it. But this is the big document, UCR 2008 change to section 5.7. Yeah.
When you say federation, you mean mostly in terms of interoperability and not so much about identity?
No, federated identity. So the DoD or large companies at this point are saying that your identity on the chat network is business valuable. And so they don't want some trader doing business as Bike Lover 73. They definitely don't want someone in the military talking over AOL Instant Messaging and doing business deals. They want you at your .mil account. And so when you're doing IM, you are your .mil account. When you're talking on your phone, you're your .mil account.
But your federation allows you to be multiple identities. You have the same, and I prefer that.
In theory, you could set it up that way, yeah. So the main vendors that I'm aware of, the idea is you're logged into your machine through your corporate identity, whatever's in your corporate LDAP. And so that is the identity you want to be. I don't know of any in a few products that or any features in a few products that I've looked at that really make it easy to have multiple identities. I'm sure you could pull that off though. But in general, they don't want, or the goal is your infrastructure is here. You have a box on your edge, and your box on your edge talks to the wide internet to another box for some other corporation or military branch or whatever we're talking about. And so those two boxes do all of the negotiation of whatever protocol streams are flowing, and it's just like you're calling your friend sitting at the next desk. So the question is, we now have a company that has purchased a large unified communication system, and they've set up an edge box that listens on the public internet, and they have a bunch of users on their IM clients that are always running. And so I could start sending messages through the front door, and I could try and get to one of your IM clients, but you're going to see pop-ups, and people are going to watch network traffic flowing, and they're probably going to know that I'm there. So the question is, can we do things where you don't know? And with XMPP, with that opening port, the first thing that you do is you open your document. So the stream is the XMPP transport, and it's the top level element of an XML document. It provides flow control, so you can send stanzas. If I initiate to you, then I can send you stanzas, and you can send me errors, but you can't send me stanzas back. You have to open up your own stream to me. There is changes for that, but right now it's still unidirectional. And so streams are also insecurely introduced. And so I open up an open TCP connection, and then I negotiate TLS if you support it. So there's two different sets of rules. There's client to server and server to server. So when I say things are unidirectional, that's server, because client only opens up a single connection and traffic flows both ways. So over the decade of rule changes, you can get no version, or you can get version 9 or 0.9, and you may have to deal with that depending on who you are, which means that any of the structure and stricture around what naming you actually use in a stream is thrown out, because they didn't think you actually had to name the thing at first. So if you're going to support it, then you're kind of lost in the woods, and there are commercial products that still do. So the opening document kind of looks like that. So it's from Google, it's to Yahoo, it's version 1. We know what it is because it's got an XML namespace, and we know that it's Jabber server because it has an XML namespace that tells us whether it's server or client. So if we're 0.9 or before, none of that stuff is actually there. You have the 2, but you don't have any of the other stuff that is absolutely required. And then the server responds. So the server response is kind of like TLS. If you're familiar with the way that works, the client says, "Hi, I'm here." The server says, "Here's all the list of stuff that I want, or that I think you can do, and you need to pick what you're interested in," which has some of the same problems of TLS, where a client can downgrade if there's something there that's really weak. So if you look at this, in theory the client can pick any one of these to do next, if it's offered. So we have the idea that we could start TLS, we could start compression if we wanted to, we could negotiate bidirectional flow of data, we could authenticate each other. Or we could use a very weak form of non-authentication to use DNS to call back and see if you're who we think you are. And if I offered all of these at the same time, exactly like this, I could actually choose none of them and keep going, because none of them are required, and they're all mutually possible or not necessary. So what should happen is the client should restart the stream every time a feature is negotiated. And the first thing you do is you start TLS, because you have to have that for authentication. And TLS should actually be required. So the client negotiates TLS, and then after TLS is established, they send a new stream element, and we start all over again. And the next set of features doesn't include TLS. It's already been negotiated, but it includes mechanisms, because you have to authenticate. So if you offer it all, the client can choose whatever they want. But if you do it in a methodical manner, the client is supposed to choose exactly what you need. And so this is kind of what it looks like. And I put that up there, not so that you can read it all, but to show you that it gets a little crazy. And this is interesting because, sure, there's this chunk for TLS, there's this chunk for SASL, there's this chunk for doing dialback if you want to do it. But the goal is to get to Open Stanza Exchange, and the server should never let you go through that without doing what it expects. And then we get to Google, because there's a neat little proof of concept out there that you can play with. The guy's got a video that you can watch, and so this is kind of a cut from the video. So you look at the stream negotiation between your Jabber GTalk client, or your Google GTalk client, the proxy that's in the middle, and Google. So the client opens it up, the server says, hey, welcome from Gmail, and it's Jabber client, and hey, stream features, I require you to start TLS. Start TLS is required. And you shouldn't actually have the mechanisms in there right now, but if you look at the SASL, you can do Google token, or you can do Google OAuth. Those are your only choices. And so the client starts TLS, and the server says proceed. Except, so if you look at that, you should not be able to establish an insecure channel and an unauthenticated channel with Google. And the little exploit that this guy wrote, this proxy, opens up a clear text connection with a plain text password auth, which are not offered, but the server accepts it. So in the end, he can man-in-the-middle GTalk, even though Google says you're not allowed to do this. So why cheat if they're just going to let you in? So for any server that advertises XMPP Federation, they have a serve record out there that points you at the right place to go. Hopefully you have to get through TLS, but how hard is it to get a certificate for whatever domain you want? If it's Open Federation, it really doesn't matter who you are. It just matters that your certificate matches the domain that you're claiming to be. And most companies have a policy, since you guys aren't users of big federated systems at this point, it's hard to ask, but I've been to a bunch of companies where the security policy is we will absolutely not federate with anybody. But we will federate with Google, we'll federate with Live, we'll federate with Yahoo, because people really want to be able to talk to their spouses and their kids and their friends. And so big bank, no, you can't federate with them, but Gmail is fine. And so with a certificate that matches my domain, I can get into XMPP. So I'm going to turn it over to Rachel to talk a bit about the questions that you can ask.
Awesome. Let's see if I can figure out how to use this mic.
Flip it on you.
Okay, I know. Hello? 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 Oh, good. Okay. At least I think. Yep. Okay, it works. There we go. Okay, I have kind of a big list of features on here, but okay, so Jason earlier mentioned that there were 314 different standards. If you look on the Jabber website, on their standards website, that's a lot. And each of those represents a different feature. And so when you have this user that Jason was talking about, who is connecting from Gmail to your corporate network, as an attacker, if I'm connecting from Gmail, what I'm interested in is what functionality is exposed on your server. That's what's really interesting to me. And 314 different ZEPs, that's 314 different unique things that are piggybacked on top of Jabber. So when we say it's extensible, we mean it's really extensible. It's a transport on top of which people can build applications. So there's like video, voice, they can search your directory. Like there's all kinds of different extensions that you can add, each of which has, like, and lots of them have very rich functionality. And so when we were starting to look at Jabber from a security perspective, that stuff is all very interesting to us, and it's definitely very interesting to an attacker. They can look at your server and they can go through and sort of cherry pick which zeps they're interested in. But to actually, but it's hard to get your hands on the actual servers to test them and see which ones are supported by each, because the large deployment ones that are used in the DoD are very expensive, and we do not have $100,000 to test each individual server. So what we did was we went and we looked at the different pieces of Jabber that are actually required to be compliant. And that's what these are. So if you're going to be a compliant Jabber server, or you're going to be a compliant Jabber client, you are going to speak this list of features, and so we're just going to go through those bit by bit. And so we were kind of looking at these and seeing what kind of attack surface they explore. If you're a Jabber component, that means you're you're a privileged component on the network. That would have been really nice. In practice, you have to have a password and you have to know the namespace for it. So that would be kind of hard to get. That would have been nice, but we can't get it, so we rejected it. Entity capabilities. So this is like when you mentioned earlier when you're opening up, you want to know when somebody is coming online. So one of your friends just came online, you want to know that. That's called presence, and so you're subscribed to their presence. So when let's say I subscribe to your presence. I subscribe to your presence, and you say, do you want, and it'll say, do you want Rachel to be able to subscribe? And you'll say, yes, sure, Rachel's a great person. And so that's kind of how that works. Every time after that, silently, you'll be able to see my presence because I'll send it over to the network to you. And if I want to know what features your client exposes, the clients all support different features too. Let's say your client lets you do voice streaming or video streaming or something like that. So that's what that is. I can see, okay, their client does do voice chat, and so I can click on a button that does voice chat over Jabber. And you explore that when you get their presence notification. Their presence notification will tell you what features their client exposes. But unfortunately, it'll pop up an accept deny dialog in most of the clients that you're going to use. So you would know that I was trying to figure out what you do, which is unfortunate for us. PEP, personal venting protocol. This is also in the list of standards. So the personal venting protocol, it also comes broadcast in presence stanzas. This is like if you have an IM client and it says so-and-so is in a good mood and they are doing such and such and they're listening to this music. So the worst you could find out there is they listen to Coldplay or something like that. It also will broadcast their GPS location. So maybe if they're on a phone and they're talking on their phone, it'll broadcast their GPS location, which would be great. That'd be fantastic. Then you could spy on people and do all kinds of creepy stuff. But it'll also require an accept deny dialog. So it's not as useful for an attacker. Chat state notifications. I could find out that you're typing. Well, you're at a computer. You're probably typing. So what is interesting that was on that list? There are a couple of things. Service discovery, multi-user chat, and vCards. And so we'll go into those a little bit more depth. Service discovery. So as I said, this is very extensible. So if I'm talking to another Jabber component, like a client or a server or another component on the network, I need to know what it supports. And you can do discovery to see what it supports. Each of the features is named. And so when I connect to, in this case, I believe it's a server, I can see what features it supports. It supports ping, private messaging, auth, search, a couple other things. I can see what the server supports. That's useful. That's how I can find out if it does any of the neat, rich features that I'm looking for. Here I can see, down here, this is kind of cool. It says it supports MUC, which is multi-user chat, and that's chat channels. And so in these systems, that's where a lot of the real juicy information is. I'll get to that in a minute. I'll go into more depth there. Here in our example, we have the water cooler channel, which has the name of which has the title of the channel, maybe the topic of conversation or something like that. There's a closed channel for paranoid people who don't want people to know what they're talking about, and an open channel where you can talk about anything. So I can actually get that just by looking at the chat server. Over here I can see that the closed channel is very paranoid. It requires a password and it's members only, and it doesn't look terribly friendly. And so that's kind of interesting to me that they have very protected channels. And if I can actually join a channel, if I ask the channel for a list of items, I can get the list of users on the channel. That's interesting. So if your company has a channel that's talking about a product, then I'm somebody that's federating with you, like either from Gmail. Do you want somebody from Gmail to be able to know that like you have this new product, they're talking about it on a channel, and all the users who are on that channel, it's going to have their names on the channel. Now I know the names of all the people that are working on that product. That's pretty awesome for me. I can, like, if I'm a competitor, I can be like, hey, that person works in that product. We don't have anybody that has expertise in that. Why don't I call them up and hire them and give them lots of money? The names are nicknames on the channel, but and you can actually change them. But a lot of them by default will give you the person's actual username. Let's see. Yeah, again, it has a list of usernames. Group chat is about community. Yeah, so this is kind of the thing that we're most interested in. Like a lot of security talks end up being, here's some fancy crypto attack, or here's some fancy memory corruption attack. But what the really interesting stuff on any of these systems that you're trying to get at is the information that's on them. If I can get access at your information, that's the most interesting part, or if I can change it or something like that. And you can get an absolute ton of information about the channels these people have, like through the federated connection. So if I'm that Gmail user talking to your company, you want the person to be able to talk to their like wife or whatever, but it's not necessarily quite a trusted connection. And but all of a sudden they can see all kinds of neat things about your company, like people like, as it says here, people like meaningful names. So let's say that it was like Apple. I'm sure there would be a ton of journalists who would like to see what their next phone is going to be called. Here they're using Bermuda swaptions to limit big bank exposure. Yeah, if you're a bank, there's probably all kinds of things going on within your company that you're going to be, products that you're working on, and banks will federate with each other. They'll have some parts that need to talk to each other, and you really don't want your competitors knowing everything you're doing. Is the room private? Is it like who's on the channel? Is everybody on the channel a director? That's pretty neat. I want to see what's on that channel. And on some level, you can say, well, you should just lock all those channels down, but that's kind of not what it's about. If you work in most people work in like sort of limited individual groups, and you talk to the same kind of people every day. You talk to maybe 5 to 10 different people in your group, and you don't know everything that's going on at your company. And the point of the group chat is to get people talking to each other, discovering information. Like if I'm in group A and somebody in group B is doing something really interesting that I'd like to know about and like my product to be able to work with, you want those people talking to each other, discovering the channels that they're talking about their products on, engaging with those people. So it kind of has to be about free flow of information. You kind of can't, if you locked it down, it would kind of destroy the purpose of having the social systems within your company to begin with. So you could lock it down, but it's probably not something you're going to do. Okay, and we'll get the other mic up here. So this is a picture of the chat system that we both used to work on. And when I say like people are talking about products and people are talking about equities and people are talking about like marketing strategies and things like that, that's absolutely what they do, and they name them after them. So if you have like super secret new product, those are definitely the kinds of things people will absolutely name a channel a product after, or a channel after other.
So has anybody?
Does this work? Let's see. You get mine.
So is anyone familiar with IRC? Y'all used it. So this was based around IRC, and this is actually a product screenshot. It's not live data, because let me tell you, the live data was actually a lot more interesting. But so when we talk about this, it's really esoteric. But I just saw a movie the other night that was trying to talk about Lehman back in 2008, when they were trying to dump all of their CDSs without anyone knowing, all in one day, to try and get out from under the cloud of what was going to come. And so you look at that and you're like, man, if I had only known about that right at the start of the day, where would I be right now? And so,
country.
non-extradition country maybe. But so this was kind of modeled on what is now UBS because the product actually came out of Swiss Bank right about the time that the merger happened with UBS. So UBS is a company that, had you been able to get at their chat channels, had you been able to get at the descriptions and topics, you would have actually seen a channel probably that was trade idea, get the heck out from under the falling rock. And I mean with actual data about what they were going to do, because UBS was terrible about this. And anybody could join because you could plug into the network and it was IRC. And so we didn't have NAC back then, we didn't have Wi-Fi, we didn't care about who got on what network. You could just plug in, you could join IRC, and you could find out every single trade that was happening in the bank at that point, which included all of the illegal stuff. So it was a treasure trove. Another great anecdote is that I have some cousins that fly helicopters, or used to fly helicopters for the military, and when they were deployed, one of them flew search and rescue for the Navy off of carriers, and the airwaves were so precious that they used AOL Instant Messenger to do flight control unless you were on approach, because that was the only time that you could actually get radio slotted in to talk to a controller. So the controller sat there and chatted all day, but then they brought group chat along, and so the group chat channels were locked down, but all of the names and things carried tasking orders and movement and all sorts of really interesting data, because it helped people find the right channel when they were on approach to a specific base to figure out who to talk to. So it's a little esoteric, but it's really quite fun to think about. A company's going to have an open group chat system. Right now, few people have it deployed on XMPP, but it is gaining ground. And this product was actually bought by Microsoft and is part of Link. So as Microsoft starts to expose more and more things to comply with DoD requirements, which used to require muck until we complained and said that they shouldn't be in there, they will eventually be back, and all of a sudden this muck data is going to start being exposed over XMPP. So one correction is the user lists wouldn't really be interesting if I couldn't get at them without joining the channel. There's a lot of interesting stuff you can get once you're a member of a channel, because the channels won't allow you to ask a NIC about user details. So you can't message a NIC, which is a different name than a username, and say, tell me about the client that's connected and all of the information about the user, unless you're connected to a channel. And connecting to a channel is a bit of an aggressive move, may cross some lines, and so we haven't really looked at that yet. But the user lists are almost always available just with a disco items to the channel without actually joining it. So you can just get that list without doing anything that's questionable. So really an interesting thing, one of the items on the very first disco info slide was something called Search 2, and luckily this product that we were testing with does not enable directory integration and user searching by default, but it is possible. Lots of places do, so you can actually start asking Search, hey, just tell me everything about the corporate LDAP because you're connected to it, and so I'd like your information. But let's say you can't do that. Jabber is pretty good. They said, you know what, doing user enumeration is bad. So they wrote this thing called ZEP 191, Simple Communications Blocking, which says anytime somebody asks you something that could be leaking information, you should just respond with service unavailable. Don't give differentiated responses, because differentiated responses leads to user enumeration. So they're trying to block it, but let's start looking at this a bit. So this is a domain JID. This is a Jabber. A JID is a Jabber identifier. It's a name. So this specifies a domain, and then when we asked the domain, tell me about the items, it popped up this chat.example.com, which is a component. And when we asked about the component, it told us it was muck, but it could tell us that it's just about anything. A bare JID is just the username at the realm. So this is a user. The user's always there, whether the user's connected to the system right now or not. And when the user connects, they get a full JID, which includes this resource identifier. And so this is an actual connected user and we can ask questions about it. We also have a channel name. So this is foreign exchange trading at the channel server, let's say. And then we have a nickname on a channel, which is foreign exchange at chat. So this is the channel. There's some guy named Bob. And the thing that Rachel was talking about is Bob and Bob are actually not equivalent, because if they're the same name, maybe we can make use of that, but they don't actually represent the same thing. So this could be Joe, and it would go to Bob if Bob actually joined the channel and said, hey, my nickname is Joe. So if we ask for disco info on a user at a bear JID, we get service unavailable. You shouldn't be telling us about that. If we ask for a full JID with a bad resource number, we still get service unavailable. If we have the resource ID and we ask for disco info, then we get a bunch of information back about the client. So we can actually use the muck nicknames and just substitute out the domain to try and get to a bear JID. We're making a guess, but it's an educated guess, and it actually works quite often because of the way that clients work. But we also have to get to this resource ID. And if we look at the way people do this, we have some hope. Spark, a popular client, uses a fixed string. Sci+, we don't even need a version number. Pigeon, the user has to type one in, but people are bad at choosing names, so maybe we could use that. Exodus, another really popular one, offers you 3 choices. So we might be able to do that. We get down to like Citron, and they add the host name, which you probably can't guess for that client. Swift does the right thing, and they generate an actual very nice random number. Google Talk does the same thing. They use a fixed version number or fixed string with a random value, and I wasn't able to check iChat. But we can't really guess that, and the thing is, we get into this mode where if we don't actually know that the name exists, then guessing a resource ID is kind of pointless. We're never going to find anything. But vCards are the last thing that was on that list. And so they're interesting in themselves. We can get information that maybe recruiters could use. We could use it for various reconnaissance stuff. But the interesting thing about vCards is they contain interesting stuff about a person, and you're supposed to have that before you establish a relationship. Maybe you don't know that Joe at GTalk is the person you want to talk to, so you pull their vCard to find out, oh, is this the Joe that I'm thinking of? And so the vCard ZEP specifically calls out that, hey, we need to worry about this whole user enumeration thing, so be very, very careful with it. And what's awesome is that if you ask for the vCard of a user without a resource ID, you find out whether they're there. If you don't, or if the user doesn't exist, you'll get back a service unavailable. But if the user does exist, hey, you get the vCard. So in the end, you can enumerate users pretty easily with some educated guessing, and then from there you could start using the resource ID problem to start actually getting at clients if you really wanted to. So, okay, what did we get? So at first we ruled out poor server implementations because that gets a little too crazy. There isn't a good standardization. And we also limited ourselves to doing things that are on the white side of legal. And so with that, we were able, even with the most secure test platform, what we ended up getting is some pretty reasonable information. And then what can we do with that? So now we know about users, and now we can start exploiting bad protocol implementation in the jumble of, in the mess that is XMPP right now. You think about HTTP, I exploit your server, and your server's probably sitting in a DMZ. You've architected it really well. You only have one opening back to a SQL database, and you're being very careful about SQL injection. So I can get into the DMZ. But in the DMZ for unified communication systems is a proxy that sends every well-formed protocol message into a specific host on the internal network. So you can get to servers, you can get to client hosts. It'll reflect out to their phones, because I have XMPP clients running on my phone, and if you don't, you should, because it's really useful. And what's even better is that XMPP initiates conversations. It's just like SIP. So SIP is the session initiation protocol. It was designed for the M-bone to establish media flows. XMPP is now the same thing with Jingle and Google Voice. Google Voice is pushing to basically do session initiation. So I can ask your client, your phone, whatever, to open up a path for RTP between my endpoint and your phone. Get it through the firewall and to whatever device you have. So we now have a path that goes all the way to the hosts that you're trying to defend and through all of the network infrastructure that was built up to defend it. And the best thing is, it's complicated. And even when you sit there and say, required TLS, and you can't connect without being authenticated, strongly authenticated, people still implement it incorrectly. Google implemented it incorrectly, and you can stick a proxy in the middle and downgrade. So, thanks. That's our talk. I guess one of the things that I would be interested in is if anybody has thoughts on their companies looking to implement this, looking to do federation. Have you guys even run into this concept before? Because I'm trying to get a sense of how much this has permeated the world outside of those of us who work on it.
Yeah, how do you guys communicate with each other? Do you use email mostly, or do you use...
My question is, why is federation better than aggregation? Like, why can't I have a client and talk to different providers that achieve my goal of different kinds of communication?
I think
Versus federation.
better is not the right tactic, right? So I don't think that's the question. What people, when you start to get to the point where you're doing corporate to corporate conversation, the reason back in like 99 that we were trying to create this clearinghouse is because everybody was worried that AOL was unauthenticated. And so they thought, if we can join two companies together, then company A has authenticated their people and company B has authenticated their people. So we at least know that they're talking as authenticated entities, which is a lie even in XMPP now. But that was kind of the start of it. But now you start getting into, this is my phone and I'm going to join meetings, because a great feature of these products is all of this PowerPoint sharing and stuff that has been really cumbersome is incredibly simple to set up. And so you can do online meetings and you can telework pretty easily, and you join with your corporate credentials. So when you set up a company-to-company meeting, you still have the same thing. I show up as Jason on their bridge, and they see me as that. And so it's not so much that doing this, or doing the big aggregation clients like Trillium and things is bad. It's just that you have to run that one client, have an account on all of these different networks, and worry about the messaging policies and the blocking policies of every single one of those networks. And companies don't want to do that. It takes a lot of management. So if they can go off and they can buy from a single vendor this all-in-one, really great unified communication system, then they're doing that now.
Also, if the DoD said you want to be federated, then
The DoD is, yeah. I mean, and the DoD is setting it up so that the DoD is in a bunch of silos, and so they actually have implementations that just to talk to each other, they need to do federation. And so they need to cross out of a DMZ into a public internet, which is a DoD network, and then cross into another DMZ into another silo to be able to talk to each other. So even for their own functionality, they need that, and they want to own their own servers. They don't want people chatting over AIM.
Yeah, so our company actually does federation with Cisco, because we're a Cisco business partner. So
Okay.
that's a lot of what we're doing is I can basically open my link client, type in a Cisco address, it sends me the message, they accept, and now we can basically chat between our systems. So
Okay.
yeah, it's actually, we've seen quite a bit of use of that, particularly with our business partners.
So do you know if you do like open federation with Link where it will talk to anybody with a cert, or is it just Cisco?
I believe it's actually open federation, if I'm not mistaken. So.
Okay. I mean, I don't know of any problems with that. I'm just curious. So,
To semi-answer your general question, Skype. Like that.
Okay.
I have a really small company though, so I mean they don't have their funds to buy anything. They just Skype each other. Before that,
Okay.
they never used Skype because it's so close.
well, Skype is actually going to start federating with XMPP. So they are joining the open world as well. And we weren't sure whether they were going to join or not because they have such a different network and such a different protocol. But yeah, they've announced that officially they are moving to an XMPP federation model. So, any other questions?
Is there any movement in the IETF to fix some of these problems?
I think the working group, so I mean, with the IETF, it's sort of the Jabber working group and xmpp.org is still the owner and the people who deal with XMPP, and then they publish to the IETF. So the working group is pretty much this same group of people. And I think they are interested in fixing these problems. One of the difficulties that I don't see them addressing well is the fact that they have such a protocol mishmash. So the new protocols, the 6000 series protocols, are very clear about what naming elements that you have to have and how you would do bidirectional communication, but they get really, really wishy-washy on exactly how you deal with names and certificates. There's an extension protocol document that starts to talk about it, but when people are working on this bidirectional communication thing, because if you have a set of, say, 10 edge servers that are actually load balanced in order to handle your traffic, and you're a big ISP or you're a cloud vendor or somebody who has an XMPP implementation, then you are going to need to open up, for one company, you could potentially have 2 TCP sockets between every one of your edge boxes to handle the load, because you don't know exactly which one it's going to land on when they establish it, and you run into the problem that, like, if you have a client here and a client here and there are edges in the middle, client A could send a message this way and it'll traverse one network path and establish one stream, but then the reverse stream, because of DNS load balancing or whatever, comes back through a totally different path, and you can't associate them. So they're looking at, because they have a lot of names and because they have this whole connection management problem, doing this bidirectional communication stuff, so I can negotiate, yes, actually, let's talk the same, or let's talk bidirectionally on this one stream, and oh, by the way, let's do negotiation of new names. So sure, we have example to Fabricam, but now all of a sudden we're adding Google on this side too, so let's just use the same open pipe. And so they have very, very wishy-washy rules around all of that, and the competing implementations are wrong, all of them. So, and even like doing vendor testing between people, major vendors, the interoperation is very weak. So they have a long way to go. I think people are thinking about it, but they're not focusing on sort of ejecting some of the chaff that's existed. They're still trying to work within the framework and keep interoperation with old versions of their protocol.
Didn't they even kind of go with their own standards organization because they wanted to be faster, more loosey-goosey than the IETF?
Well, I mean, that is the ZEP. So the ZEP process is intended to be IETF light and publish into the IETF. So they follow the same process where things go through experimental and draft standard and then become standardized, and then you run into the problem that they version that, but they don't put in a way to tell which version of the protocol you're talking on some of them. Some of the ZEPs are really well written, and some of them are less well written. And so that's, I think they are working through this, but it's a very large distributed organization. So.
It's not sad because it's presumably the original reason why XMPP was created, right? Was to have this, all of our chat systems can all talk to each other, and we can, and then it's kind of been broken by its own creators or whatever.
It has.
Yeah.
It's really.
The happy thing there is a happy thing. With the push from the DoD, it has forced big vendors to start working together. And I suspect that we will see in the next couple of years much more push from Cisco, from Microsoft, from Skype, from IBM to try and force this issue and make sure that people both talk the same protocol so that they work together and start throwing out some of the bad behaviors that they've had to maintain. So, and we shouldn't forget ISOD, who didn't know that I was actually testing with their system, but they actually are a really good commercial XMPP vendor. So.
Yeah, what surprises me with that is that when SSL was growing up, and NIST came in and made them clean up their act and said, we won't accept it at the government until you fix this, this, and this, and that's what gave us TLS.
Yeah.
So it surprises me that NIST would let the DoD accept XMPP with all this shit in it.
NIST is out of it, actually. NIST and the DoD are within some protocol space. NIST has domain, but DISA is the communications group. And so this big DoD document and testing effort is all being driven by DISA, who was put together to make sure that phone systems interoperated, which seems kind of crazy if you think about it, but apparently for decades phone systems didn't work together when they bought them. And so this is what DISA did for a long time. And so now they're working on XMPP and trying to force vendors to go through a standardization process. And so, I mean, some of the stuff that you will see come back from, so DISA is partly working off what are called the compliance suites, ZEP. That screen of X's and check marks and stuff is the 2010 compliance suite, which XMPP requires. And then DISA has come in and said, on top of that, we require you to do these other things because we need them. One of those is multi-user chat. And so that will be coming back in the DISA process. It's just that it was so unformed that what they found is that most of the vendors showing up are SIP systems that are creating bridges to XMPP, which is really, really fun because within presence models, you can there's some difficulty in mapping SIP and XMPP presence models, which have caused some really bad implementations. And so when we talk about getting pop-ups, there's a future hope that maybe I can piggyback on the fact that there's this changeover and get in to presence accepting without actually getting pop-ups. But because of those bridge systems, they jettisoned Muck because it was too confusing to map. But it will come back probably in the next year or two. So. Thanks.